Let's move on to level 13. Find the equation and graph the table of values in the Cartesian plane. Choose an appropriate scale. Let's graph this first. I have 1 and 120. Now notice I'm going up by 5s. To get to 120, if I went up by something a little larger, say I go up by 10s, that might be a little bit easier. Hold down the shift, press the down arrow, and I'm trying to get up to 120. There it is, 120. 120 is right here, and then it's 260. Bring that up till we see the 60. Here's my 60. 260 is right there. I need my line drawing tool on. 430. So 430 is right here. Drag that up so you can see the numbers. 430. And then we have 620. So 620 is right there. Notice it's curving nicely. It's predicting the function that we're using. If we step off of that, like let's say I tried to graph that here, it gives me this cheesy looking line graph. What if I put it back? It's a nice curve. 15.8 is right there. Whoops, a daisy. Nope, 15.8 is right there. When I was wrong, it's telling me I'm wrong because I've got this line graph. Like it's just connect the dots. If I put it to the right point, I have a nice curve. 15.8, 26. Scroll that up. 2246 is right here. 24.5, 24. I'm going up by 2, so 245 is going to be right there, and it's not going to let me click there even. Zoom in on that point using the magnifying glass. We were at 24, which is still here. This is still 24, and we want to go through 6. 24.5, which is right here. If you don't like that this is 22.5, you can change the X scale. Smaller numbers. Here's 20, here's our 24. Then we have 120. I'm going to go up by bigger numbers like that. We're going up by 5s, so let's go by 10s. I'm going to get to 120 by dragging this back. My 120 is right here. It's 120. So I can just click right there. Double click on the magnifying glass to get back to our original magnification. Our X and Y scales aren't great because I don't see the whole curve. Zoom out tool, click on the origin. Now I can see my highest Y value and my highest X value. If I scaled up at all, like if I chose a smaller X, it would be off the screen. This is inverse variation. Inverse variation is always of the form Y is equal to A over X. Y is equal to A over X. To find the A, I just cross multiply the X that way. So we have X times Y is our A value. Notice if I multiply 1 times 120, I get 120. If I multiply 2 times 60, I get 120. 4 times 30 is 120. 6 times 20 is 120. 15 times 8 is 120. 20 times 6 is 6 times 20, and so on. Okay, they're all 120. Our A value is 120, and that gives us Y is equal to 120 over X. Our equation is Y is equal to 120 over X. This is called inverse variation. We can tell it's inverse variation because as the X's are going up, the Y's are starting up and they're going down. Notice that they're the opposites of each other. 120, 120, and 1. We have our equation and we've named the function. Now we can press return to see if we're right. Yay. 1 and 24. 21, 2, 3, 4, right there. 2 and 12, right there. 3 and 8. That's 3 and 9. 3 and 8 is right there. 4 and 6, right there. 6 and 4. 8 and 3. 12 and 2. 24 and 1. And this continues on this direction. Our X and Y scale is fine. I don't have to adjust this. Like if I adjust it here, let me click on the origin for a second. If I tell the X values to get smaller, that'll make the graph bigger, but notice it goes off the screen. Back to there is good. Off the screen, on the screen. We've graphed it. It's inverse variation. As the X's are going up, the Y's are going down. Notice that if we multiply the X times the Y, we get a constant. That constant is our A value. Like Y is equal to A divided by X. If I cross multiply, we have X times Y is A. XY is equal to A, and our A value is 3 times 8, 24. 1 times 24, 24. A is 24. If I did 2 times 12, that would give us our A value, which is 24. 24 equals A. Our equation is Y is equal to 24 over X. Y is equal to 24 divided by X. The name of this is inverse variation. Press return to see if we are right. All right, and that is it for level 13. Have a good day.